Okay, so we just knocked out the glide reflections. Now, what the heck is going to happen when we reflect an object over two parallel lines? Me curious. What's going to happen? All right, so we're going to reflect over y equals 3, then y equals -4. All right, so B is 2 above, so B prime, 2 below, similar with C, and then A is 6 above, so it will be 6 below. I believe that's what it should look like. All right, and we got this very beautiful pink triangle. Cool. Okay, now let me get a weird color. Let me get this swamp green. Now A is 1 above, so A double prime will be 1 below. B will be down here. And C will be down there. Cool. All right. Well, let's just focus on this first one and this last one. All right. What single transformation could I have done? Well, notice that these triangles are oriented the same way. All right. And in fact, I know, I could have just slid it straight down. All right. So I could have just done a translation. All right. Now, how far did I go down? Let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Translation down 14. Okay, I didn't write in coordinate notation. I just used the English language for that one. Now, how far apart are these parallel lines, IDK? Let's count. 1, 2, 3, 4, 5, 6, 7. 7. Okay. So what is the relationship between the parallel lines and how far you've translated? All right. Translation is double. Let's write this. The translation distance is doubled the distance between the parallel lines. All right, the parallel lines were 7 apart. The translation was 14. Okay, the distance was doubled, which kind of makes perfect sense. Well, not kind of, it exactly, precisely makes perfect sense if you think about it. When you look in a mirror, if you're 4 feet from a mirror, your image looks 8 feet away from you. You double the distance. If you look in a mirror and your image looks like it's 10 feet away, that means the mirror is only 5 feet away. Okay, and then we got it very mathematically written here. Reflection across parallel lines theorem. The composition of two reflections over parallel lines that are h units apart is the same as a translation of 2 h units. So in this case up here, let's just relate this to this problem. It said, well, these lines were 7 apart. So the translation was 2 times 7, also known as 14 apart. So that's what it means. Cool. 2 parallel lines are 2 units apart. If you reflect a figure over both, how far will the pre-image and image be? All right, so what's this saying is that the parallel lines are 2 apart, or 10 apart. So we got some lines. They're 10 apart. All right, image, we'll just do a smiley face or a star. How far will the stars be? Well, it's going to be 2 times 10, also known as 20. So that's the answer right there, 20. Now, similarly, we got parallel lines All right. We'll just use a star. We reflected the star over this line, then the other line. They're 28 apart. How far are the parallel lines? Well, it's going to be half. It's going to be 28 divided by 2 in this case, also known as 14. Okay? So, that's some problems. That's another theorem. So we have a glide reflection. Now we have reflecting over parallel lines. Naturally, now next, what are we going to do? We're going to do a reflection over intersecting lines. All right, so we're going to take this. We're going to reflect triangle ABC over the x-axis and then the y-axis. Are you guys ready? X-axis, don't forget it's this one right here. All right, so C prime, B prime, and A prime. Hopefully you're starting to feel pretty good about reflections. All right, and then we're going to do this again over the y-axis. Why? This is what the problem's forcing us to do. I didn't hit that perfectly. All right, so B is 2 to the right, B prime will be 2 to the left, C double prime, and then A double prime. Okay. So, it's got a follow-up question. What size angle is formed by the intersection of the x and y axis? Well, it's just really asking right here. The intersection of the x and y axis is 90 degrees. Why is it asking me this? Well, what single transformation could I have done to go directly from triangle ABC to triangle A double prime, B double prime, C double prime? What could I have done instead? Well, notice. Let's see how good I can draw this. Probably not very, but I could have rotated 180 degrees clockwise around the origin. All right, I could have done that instead. All right, so when you reflect over intersecting lines, a double reflection over intersecting lines, it's the same as a rotation, double the degrees of the intersection. And we actually have that written right here very mathematically. So, a composition of two reflection over lines that are intersect at x degrees is the same as a rotation of 2x degrees. So let's pause and relate it. All right, we had this 90 degrees here. We reflected. All right, intersection was 90 degrees. So the rotation was 2 times 90, also known as 180 degrees. All right, the center of rotation is the point of intersection. So in that case right there, it was the origin, so it was just 0, 0 of the two lines of reflection. So let's knock out some 2 practice problems and then move on. 2 lines intersect at 83-degree angles. All right, so let's just go ahead and draw this. Drawing's so important. All right, again, and it's just more for reference, we're gonna call that 83-degree angle. All right. So some image, we'll just do a circle. This circle is reflected over this line to get some circle, and then again to get another circle. All right, how far will the pre-image and image be? This means how many degrees? It's just gonna be 2 times 83, also known as 166 degrees. Then we got another one. Again, we'll draw a similar picture. All right, now this image gets reflected over here, then reflected over here. All right, this whole thing is 244 degrees. All right, that's how far apart they are. What's the intersection? What's this angle measure? Well, this is just going to be 244 divided by 2, also known as 122 degrees. All right, and that's that theorem right there. All right, so in this next video, we're gonna practice these theorems and just do some fun